Hello. In this video, we want to go ahead and look at an application. A small company manufactures and sells bicycles. The production manager has determined that the cost and demand functions for Q, where Q is greater than or equal to 0, bicycles per week are C of Q equals 10 plus 5Q plus 1 over 60 Q cubed. And P equals D of Q equals 90 minus Q, where P is the price per bicycle. A, find the maximum weekly revenue. B, find the maximum weekly profit. And C, find the price the company should charge to realize the maximum profit. Okay, so on A here, we want to find R of Q, the revenue as a function of the quantity supplied. Well, it's not really that. We want the actual price, to be honest with you. Well, revenue is price times quantity. Actually, no, let's make it of Q. There we go. So, R of Q equals P times Q. Well, here's the thing. I know that P is already 90 minus Q, which is the demand equation. So replace this P with this entire 90 minus Q. So all of that is replaced with all of that. So this is going to give me 90 minus Q times Q. And notice that I can then distribute the Q. And this is going to give me 90Q minus Q squared. And this is the revenue function. Notice that it is, in fact, quadratic. And we want to find the maximum weekly revenue. To do that, we first need to find the derivative. So R prime of Q is 90 minus 2Q. And find any critical numbers here. To find critical numbers, take the derivative and set it equal to 0. Subtract the 90. Divide by negative 2. So Q equals 45. Now, that Q equals 45 is just a critical number. It doesn't guarantee that it's a maximum or a minimum. Now, 45 we want, and it's the only critical number here, so we want a number to the left of 45 and to the right of 45. So to the left of 45, let's use, well, 0. And we're using the derivative here, so R prime of Q. And to the right of 45, let's use 90. Well, if you plug in 0 in for the derivative here, so 90 minus 0 is 90. It's positive, which means it's going up from left to right there. And beyond the 45, we can plug in the 90 down here. Negative 2 times 90 is negative 180, plus 90 is negative 90. So this is going to be negative going to the right. So this 45 is in fact a relative maximum because because of the first derivative test. It's going up and then down. So going up then down, and 45 is part of the polynomial domain, so we're good. To find that actual maximum revenue, we just find what is R of 45. Well, you can just type that into the calculator if you want. Now, if you type it in, you're going to get 90 times 45 minus 45 squared. And what you get from that is 2025. So the maximum revenue is $2,025. And notice that the maximum revenue occurs when they produce 45 bikes in a week. Okay, B. B says, find the maximum weekly profit. Well, the profit as a function of Q is the revenue as a function of Q minus the cost as a function of Q. Now the revenue in this case we determined was 90Q minus Q squared. And then subtract off the entire cost function, which was, in this case, 10 plus 5Q plus 1/60th Q cubed. Distribute the negative. This gives us 90Q minus Q squared minus 10 minus 5Q minus 1/60th Q cubed. Okay, good. Now, notice that we can combine like terms, and I want to put this in descending order. So this is going to give me negative 1/60th Q cubed minus Q squared. 90Q minus 5Q is positive 85Q. And then minus 10. Good. And this is the profit as a function of the quantity created and sold. So if we're trying to find the maximum weekly profit, we need to first take this derivative. So P prime of Q, bring the 3 down in front, negative 1/60th times 3 is negative 1/20th, and then Q squared, minus 2Q plus 85. Good. And at this point, we just solve that by setting it equal to 0. So we have negative 1/20th Q squared minus 2Q plus 85 equals 0. And honestly, at this point, I'm going to multiply everything in there by negative 20, making this positive Q squared. Now, multiply everything by negative 20. So positive Q squared, positive 40Q, and what is 85 times 20? 1,700, so it makes that minus 1,700. All equal to 0. My recommendation is probably to go ahead and just use the quadratic formula. So Q would be negative B plus or minus the square root of B squared minus 4 times A, which is 1, times C, which is negative 1,700. And then all over the denominator of 2 times 1, which is 2. Good. So we need to go ahead and type this in as negative 40. And then I'm going to start with the minus first. Minus square root of 40 squared minus 4 times 1 times negative 1,700 all over 2. And with the negative, that tells me that Q would be negative 65.82575695. Now let's do that again, but this time use the positive. By the way, my recommendation for this is to do second enter if you just typed it in, and that'll be able to make it to where you can just use the arrows and change the negative to a positive. And that gives me 25.8257569. Excellent. Now, obviously, I need to get rid of that negative 65. The reason I need to get rid of it is because, well, frankly, there's no such thing as making a negative 65 bikes in a week. But that 25.82 is a problem as well. We want to go ahead and round that to either 26 or round it down to 24, and we can't guarantee one or the other. So what we're going to do is we're going to test both of those, 24 and 25 and 26. But this is our critical number. So on the number line, notice that that critical number is 25.8257695. Awesome. The question is that a maximum profit or a minimum profit? To show that it's a maximum profit, we're going to go ahead and use some test cases. So I'm going to go ahead and use 0 to the left because, well, frankly, why not? I generally prefer that. Now, for the number to the right, I might as well do 26. Awesome. Excuse me. Alrighty. So now that we know that, let's go ahead and find out the P prime. Well, the P prime of 45 is... Sorry, P prime of 0. My apologies. P prime of 0 is 85. So at the 85, that means that it's positive, which means that this is going up from left to right. Now, P prime of 26 is negative 4/5. That makes that negative, which means it's going down from left to right in that region. Therefore, this critical number is a relative maximum, and that means that this 25.825695 is the relative maximum. But remember, we don't know if we want to use 25 or 26. We're probably going to use 26 because it's so much closer to the 25.82, but that's no guarantee. So what we need to do is we need to go ahead and figure out what is P of 25, and then what is P of 26. So if you just take those values and you type those into the calculator, so at 25, you're going to get the following. You're going to get, where's that? Well, sorry. $16.25. Nope, sorry, that's the wrong one. Alrighty. I'm going to the bars on this. Of 25, math 2 enter. There we go. 1229.583333. So 58. Good. Now let's do the same thing here, except this time do this for 26. And math 2 enter. 1231.07. So there you go. 26 is in fact where the maximum will occur. So what we want to find the maximum weekly profit. So the maximum weekly profit is $1,231.07. Awesome. Now notice that this actually, the maximum profit occurs at a different number than the maximum revenue, which is interesting. And the reason for that is because of the interplay between the revenue and the cost curves. So just because you can get a maximum revenue, that doesn't guarantee that maximum revenue produces the maximum cost. In fact, it almost always doesn't. Usually, the maximum profit usually occurs before the maximum revenue. So the maximum profit here is, in fact, less than the maximum revenue, or it occurs before the maximum revenue. So there you go, 1231.07. Now for letter C. Find the price the company should charge to realize the maximum profit. Now in letter C, notice that what we're wanting to do is we're wanting to say, well, where does this occur? This occurs at Q equaling 26. So on C here, if Q equals 26, go up here and notice that we can figure out what P is by plugging 26 in here. So that means that P is 90 minus the 26. So 90 minus 26 will give us what? 64. So there you go. They should charge $64 per bicycle. And there we go. Alrighty, here's pretty much everything we just did. I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.